Hello, in this video, we're going to be talking about the change of base formula. To introduce that, let's think about something we've talked about recently, evaluating logarithms. Say we wanted to evaluate log base 2 of 50, and we want to figure out what that is equal to. So we could think about in terms of, well, we can make it into an exponential form. And that would look something like 2 to an unknown x would be equal to 50. Now, if we think about the powers that you can raise 2 to, if we do 2 to the 5th, that's 32. 2 to the 6th is 64. 50 is right in the middle of those two. So we know our answer should be somewhere between 5 and 6, but that is as specific as we can get. In fact, if we grab a calculator and try to evaluate this on our calculator, we could push log button of 50 and hit enter. We get an answer of 1.7. But that's inaccurate. That's actually finding log base 10 of 50 and having it equal 1.7, which is not the answer we were looking for. We need to use the change of base formula in order to determine the answer to our question above. And the change of base formula, as you can see right now, is if you have log base b of a, you can write that as log of a certain base of a divided by log of the same base of b. And it turns out that that base of x could be any number you want. X can be any base. But the easiest thing to do for this process is to use a base of 10 because that is what the calculator already has programmed. There's also another option with using a base of e, but we will cover that in a different video. So we want to say over here, easiest to use base 10. And that's because that's already programmed into the log button on our calculators. So if we think about the problem up at the top, if we wanted to do an example where we have log base 2 of 50, that would end up being log base 10 of the top number, 50. And then we have log base 10 of the bottom number, 2. And that would end up giving our answer. So what really we're going to enter in our calculator is log button 50 divided by log button 2. And let's grab our calculator. So now that we know we can do that, well, we have now log of 50 divided by log of 2 equals 5.64. And that is much closer to our estimate from earlier when we thought that 2 to the 5th power and 2 to the 6th power were on either side of 50. And now we can see that it is exactly 5.64. So let's put that back into our original problem to see if we're really doing this correctly. So if we take this original problem, we could write that as 2 to a certain power equals 50. And if we look at our calculator, if we use that answer, so we have 2 to the power of this answer, and we hit enter, that's about as close as 50 gets. Very, very small decimal point there, basically the same as 50. So we could say that this x is what we were looking for initially. And we can see there an example of the change of base formula working for us. In our second example, we are asked to evaluate log base 5 of 30. We would first want to write that as the change of base. So we would write it as log of base 10 of 30 being divided by log base 10 of 5 first. And then we would put that into our calculator where we were just doing log button 30 divided by log button of 5. And so that means in our calculator, we are doing log of 30 divided by log of 5. And that equals about 2.11. And remember, what we're finding with that 2.1 number is that we wanted to figure out from this first logarithm, 5 to what power is equal to 30. How many 5s would we need to get up to 30? Well, we know it should be between 2 and 3 because 5 squared is 25 and 5 cubed is 125. That's a big range. And so now we know 2.11 should get us to 30 if we raise 5 to that power. And we can check on our calculator 5 to the power of that answer does in fact equal 30. So 5 to the power of about 2.11 equals 30. We checked our answer and it is indeed correct. And that summarizes everything you need to know about the change of base formula for logarithms and how to evaluate them using your calculator.